Hello guys, welcome back. So in past few lectures we were studying about the bubble sort, insertion sort and selection sort, right? So in this quick video I'm quickly going to discuss about like the comparison between these three, right? Which one is best, which one is not that much best, we can say, right? So here is a table of these three like algorithms for time complexity and space complexity, right? So let's try to understand this for a minute. Okay, so for bubble sort, the time complexity in best case scenarios we have O of n. Okay, so in case if we have already almost sorted data, then we just have to look through the array or any data just once and then we'll be done with it, right? And the same case is with this insertion sort, right? So here also if we have the already almost sorted data, okay, then we just have to loop through it once and then we are done with it, right? We just have to make sure like everything is sorted. We just have to check all the elements just once, right? That's why we have time complexity as O of n in best case scenarios. Okay, but this is not the case with selection sort, because here it doesn't matter if the array is already sorted or not, it will keep on checking the array, or we can say any data set, like it will keep on sorting it, right? Even though if it is already almost sorted. So that's why the time complexity of selection sort is O of n square. Now if we talk about the average case where we have like few elements which are unsorted and few elements which are sorted, we can say half elements are sorted and half elements are unsorted. In that case, like all these three algorithms will have time complexity of O of n square, because they are going to run multiple loops, right? And time complexity in the worst case, if we have totally unsorted array, okay, or unsorted data, then obviously it is going to run multiple loops, like loops inside of loops, or if you're using while loop or any other loop, anyways there will be multiple loops, right, in those algorithms. That's why the time complexity is O of n square for these three, right? Now if you talk about the space complexity, if you might have noticed, we were not creating any sub array or any other what to say data structure inside of those algorithms, right? We were swapping everything in place. That means we were not creating any other array or any other object or any other data structure, right, where we are storing the results and then we are returning it. We were not doing that thing, right? We were replacing, or we were positioning, or we were setting the positions of every element in place, right? So within that array, which we got, in the same array we were replacing, we were adding or removing the elements, right? We were not creating the new array. That is why the space complexity will always be O of 1. Okay, since there is no other data structure which is getting created, no other array, no other object is getting created, so time space complexity will be always O of 1. Okay, so this is all about this chart. Now let's try to see, now let's try to visualize it, whatever I have just explained. Okay, so let's go back to this visual algo first and then I'll get back to this in a minute. Okay, so let's just go back to this visual algo, right? And if you don't have the link still, then I'll attach the link of these two websites in the description of today's video. So don't worry, you just have to check the description and then you will get the links, right? Now what I'll do, I've already created an almost sorted array, right? So just to show you the best case scenarios for all these three algorithms. Okay, so I'm creating an array. I think I've already sorted array. I'll just do a slight modifications. I think I've already done it. Okay, so 1 2 4 5 6 7 6. Okay, so I've just added this unsorted 6 here, right? Rest everything is sorted here. So now let's just click on go, and I think now we have that updated array here: 0 1 2 3 4 5 6 9, right? So now let's quickly sort it. Okay, so as soon as I click on sort, as you can see, right, so what happened just now, we are in bubble sort, right? So it swapped the array, it checked in the first loop, in the first iteration. What happened, it found there is one element which is unsorted, right? And then it swapped it, it sorted it, and then it again ran just one more loop to make sure every element is sorted, and then the loops finished, right? So it stopped iterating through the elements. That means there were just two loops, right? So let me show you once more. I'll play it again from here. Okay, so Just see. Okay, see, there was just one 6 which was unsorted, so it got sorted, it got swapped with its original position or with its correct position, and then again one more loop ran, which is basically to make sure like the array is sorted or not. And if it is sorted, then it stopped running the loops, right? So this is how bubble sort works, or we can say it is highly performant in the case of what to say almost sorted data, right? Now let's see that in case of insertion sort. Okay, here also I think I have to create or what. Okay, so I have to click on go again and again every time, that's fine. So now we again have this unsorted data here where just this 6 is unsorted, right? Now if I click on this sort, okay, I have to just pause it for a minute because I don't want this thing to happen, this thing to appear. Okay, so now I'm playing it. Okay, so let's see what happens. Okay, see, it is looping through the array just once to see which element is unsorted, and then that's it. Okay, because there was already almost sorted array, there was just one element which was unsorted. So it looped through the array, it checked the elements, and then it sorted them. And within just one loop, it finished it, it sorted everything, and then it finished running, right? So this is how we can say like this is why insertion sort is also like a highly performant algorithm in case of almost sorted data. Okay, now let's see an example of selection sort. Okay, so here also I have to click on this go, and then I have to click on this sort, and before that I have to just remove this annoying thing, right? So now I'm playing it, just see what happens, right? We have already almost sorted data where this 6 is just unsorted, right? So I'm playing it. Okay, so if you see, it is still running multiple times for every number from the beginning, right? Even though we have just one unsorted element, but still it was running from the beginning, it was checking all the elements from the beginning, and it is time consuming, right? Okay, so that is why we say like the bubble sort and insertion sort works well in case of what to say almost sorted data. Okay, but that is not the case with the selection sort. That is why I mentioned the time complexity of selection sort in the best case also is n square. Okay, so now let's see all these three algorithms together in the this website. Like I think it's algorithm sorting algorithms animations, right? So you just have to focus on these three algorithms, right? Insertion, selection, and bubble sort. And I'm going to play nearly sorted button, right? So here you just have to focus on these three blocks. Okay, so these one will be for insertion, selection, and bubble sort for nearly sorted data. Okay, so just see like how these three algorithms sorts data. Okay, what's the performance of these three, right? So if you see, insertion sort and bubble sort finished quickly, but still our selection sort is running, right? Even though if the data is almost sorted, but still it was the one which finished at the very end, right? And don't worry about these things because we are also going to learn about these some of the more advanced algorithms. But for now, since we have already learned about these algorithms, we just have to focus on these three. Okay, so this is the like basic difference between the selection bubble and insertion sort. And in insertion sort, like I would like to add one more thing. Like it is also one of the best algorithms in case if you want to update the data in real time. Okay, so what happens is, let's say you have an array, right? And you have to, there is a use case where you have to keep on inserting new elements into that array, right? You have to keep on inserting new numbers or new elements, what we can say, inside of that array, and you want it to be sorted every time. Okay, so in that case insertion sort can be the best option for you. Okay, this one you can use to keep your array sorted in real time. Okay, so that is what I wanted to add at the end. Okay, so yeah, in case if you don't have these links, then I will add them. Okay, this is all about like a comparison between the insertion, selection, and bubble sort. Okay, so this is it for today's video. Now from the next video onwards, let's learn about some more advanced algorithms. Okay, and as usual I will try to explain them in best way possible so that you can understand that easily. Okay, so don't worry about that, like if it is a advanced or it is complex, doesn't matter at all, because I'm going to explain you in that way. You will learn that very easily. Okay, you will learn that in an efficient way, right? So yeah, this is it for this lecture. See you in the next one.